So dear students, in this uh, video we are going to discuss the procedure. So what is our T is summation of all the bi's plus summation of all the xi's, because in specific example here, if you will see, this is our total elapsed time, x1 plus x2 plus x3, but in general this is nothing but x1 plus x2 plus x3 plus x4 plus x5, because we are having 5 works. But here x4 and x5 is 0 0, that's why we have not written. But in general, in any problem they may exist, that's why total elapsed time is summation of all the bi's plus summation of all the xi's. Fine. So that's why this is the in general. Here this is fixed, only the variable quantity is this, and we have to minimize this quantity. Now to find out this quantity, what is x1? X1 is, as per this example, x1 is exactly a1, so that's why x1 is a1. Now x2 is, can be understood here, x2 in our case is this. You will see, this is machine A, this is machine B. So now there are two possibilities, A, B. Up to here A1 and A2. Now here, for example, in this case, this is our x1, and now this will be the B1, and this will take the another ideal time. This is our case. But second possibility may be that here is A1, here is A2, here is x1, and then this may be B1, and this is, so this is the end point. This is greater than this. However, here is, this is less than, this is less than, this is greater than. Fine. So in this case, x2 is equals to what? A1 plus A2 minus x1 plus B1, or B1 plus x1. In this case, here you can see that there is no requirement of ideal time, because this will finish at this point. However, A2 is already finished before this, and that's why directly pass to this and then start the functioning. So x2 is 0, no ideal time required, So we have combined these possibilities here. If A1 plus A2 is greater than B1 plus x1, this case, then x2 is evaluated with the help of this formula. This is already written here. And in this case, when A1 plus A2 is less than equal to x1 plus B1, then x2 is 0. So this is written here. Fine. Now when we can combine these two with the help of maximum. So maximum of this quantity, and because either this may occur or this may occur, so we have to combine these two. So this in short can be written as summation of ai minus summation of bi minus summation of xi and 0. Here summation is from 1 to 2 because a1 plus a2. Here summation is from 1 to 1. Fine. Now just take the sum x1 plus x2. That means adding x1 in here. So x1 plus x2 is equals to x1, but x1 is a1. So we have to add a1 in here as well as here. So when you add here a1, so what we'll get? We will get summation of a1 plus a. But what is a1? A1 is actually x1. So this will cancel out. So this will be cancel out. So we have only these two terms, this and this. So that's why maximum of summation of ai minus summation of bi, and here we have to add x1 here. So that's why, but x1 is nothing but summation a1. So that's why we have taken summation ai from 1 to 1, because a1 is equals to x1. So this 0 is now nothing but summation of ai after adding x1. Fine. Now find x3. Again apply the same concept. So maximum of summation of ai minus summation of bi minus summation of xi and 0. where I varies from 1 to 3, I varies from 1 to 2, I varies from 1 to 2, just like this. Here is 2, then here is 1 and 1. So if there is 3, then 2 and 2, and here should be 0. Now add x1 plus x2 both sides. So x1 plus x2 here, so we get summation of this maximum. Now add x1 and x2 here, so this will be cancel out, so we have only this term. And here we are having summation x1 plus x2, but x1 plus x2 is this quantity, this and this, so that's why here we are having this and this quantity. They are copied and pasted here in place of 0. So that's why we are having three quantities here, this, this and this. Fine. So this will be done on and on. So finally we are having summation of xi from I equal to n to n, which is denoted by DNS, a function of the sequence S, which is nothing but maximum of this quantity, and so on. So finally in n dimension we are having this summation I starts from 1 to n ai minus summation I equal to n2 minus n bi. Then again reduce your n, because here is 3, then here is 2, then here is 1, so decreasing order. So that's why here we are having I equal to n2 minus 1, I equal to n minus 2. In the next one we are having I from n minus 2, and bi will varies from I equal to n I equal to 1 to n minus 3, and so on. And finally we are having single term, which is I equal to 1 to 1 ai. So this is the formula. So now we are compressing this in a single notation, because all the terms are of similar kind. Summation I equal to 1 to u ai minus summation I equal to u minus 1 to bi, where u varies from 1 to n, and you will cover up all the maximum parts. Fine. So this is our DNS. Now our aim is to minimize DNS. Fine. So this will be done here. So this minimization of DNS is done with the help of John and Bellman principle, which is explained here. So first step is select the smallest processing time. Select the smallest processing time from the list AI and BI. Time is given already you in terms of A1, A2, A3, B1, B2, B3. So from this list, find the smallest one. If there is a tie, then either select AN, AI or BI if there is a tie. But if the minimum processing time is AR related to the Rth job on machine A, then do the Rth job first. If it is related to BS, then do the Sth job last. जो भी A मशीन पे होगा वो पहले होगा, जो भी B मशीन पे होगा वो बाद में जाएगा. This is the simple concept. Cross off the job so assigned, and also machine times from the both the list. That is the decision also will be applied to both the machine. जो भी decision होगा चाहे वो AR से आए या BS से आए, वो दोनों मशीन पे लागू होगा. So we have to cross off the row. Fine. We will see in the example. After the step 2, again find out the minimum time from the remaining n-1 jobs, which may occur corresponding to A or B. If related to A, then do the job first. If that is related to B, then do the job last. This is the simple concept. Continue the process in the manner till all the jobs have been done. The resulting sequence will minimize the total elapsed time T and shall be the optimum solution. Fine. So now let us understand the example, and we will explain this example in the next video. Thank you.